Cloud Performance Engineering in DevOps, SRE course. So before we get started, let me introduce myself. My name is Roshan. I am with Isha. I have been taking training from last 8 years. With Isha particularly, I am from last 6 years. Okay. On my technical experience, I have 18 years of IT experience. I started my career as a Java developer, been into performance engineering for about 6 years. Yes, as a developer, 3 years. As a performance engineering, I was 6 years. Then I was into Linux admin, DevOps admin, right? Currently, I'm working as a principal SRE, site reliability engineering principal, with one of the reputed giants of the world, handling millions of transactions per second. Right. On the cloud part, I have been working on multiple cloud. I have been working on solution architecting in AWS, Azure, and GCP, Oracle, OCA as well. I was working with Oracle for brief time. Okay, so that's background about me, friends. Okay, so what this course offers. So we are going to talk about what is this course, the course curriculum. That's the agenda for this session, right? We'll understand who should join this course, how it's going to benefit you, right? What is the thought process of coming up with this course, with this syllabus, right? So we'll discuss that. Okay. So before we get started on the details, I'm going to ask you a very simple question to all of you. Very simple question. Based on your experience, what you understand about IT and what's currently going on in the market, what are the expectations? Let's answer this question, right? Okay, very simple question, friends. Do you all agree, or do you see in current IT world that performance engineers are expected to know these technologies? The names are DevOps, microservices, containers, cloud. Do you see it's a requirement for all of us here in IT, irrespective of the skill, whether you are a performance engineer, you are a DevOps engineer, or you are into an admin, or you are a manager leading a team, you are into support role, or you are a developer? Do you think, friends, is it required? You can use the chat option, or you can unmute yourself as well. Feel free to. We'll have a very interactive session, and I'm going to make sure that your 1 hour time is worth today with me. Friends, I need your inputs.
Yes, Roshan, it is required for everyone.
Okay. Right. Do you want to elaborate on that? Why do you think so, Rajsekhar?
Yeah, hi Roshan.
Yes, Amit.
Yeah, this is basically required because if we are working in any organization, so today's market needs to handle everything by like it's a performance engineer to doing the things as you can say it's a performance engineer. So doing like it's a deployment and continuous deployment. So all these are required. Yes.
Okay, perfect. So I got two yeses. How about others? Let me see the chat also. Yes, I'm seeing the chat. Hemant is saying yes. DVR.
Hi, Rosh. This is
Yes.
Murugan.
Yes, Murugan.
So nowadays, everyone is expecting everyone should know everything. This is kind of IT world now we are seeing. All the roles nowadays they're expecting to know all the kind of skills, especially for production support. Also, this kind of skills required nowadays. It is getting transition to SRE nowadays from production support.
Right. So let's not say all. Yes. So let's say if you are a performance engineer, they will not expect you to do the development work, right? Or they will not expect you to do a QA functional testing work or a security testing work. So let's not generalize that.
Yeah, only testing will not be involving. Otherwise, coding also expected nowadays,
The
like a small kind of
the
fixes.
scripting, automation, right, Murugan? When you say coding, basically let's say if you are a performance engineer, right?
Hmm.
On the coding part, yes, they expect you to optimize the code. They will not expect you to write the code,
Yeah.
or they may expect you to automate few things, right, to which can um, help you in increasing the productivity. And we have
Yeah.
right nowadays we have Gen AI tools, our
Yes.
great friend, right? We should not start from scratch. Nobody should start from scratch writing anything, whether it's a script or anything, right? So yes, with the current emerging Gen AI trend, yes, uh, the expectations have increased. Yes, definitely. We are expected to be more productive nowadays. Absolutely, yes. Everybody is expected. Every company is aligning towards using Gen AI tools. Use Gen AI tools. Nowadays, we are using Gen AI tools for every other activity. If you have to take a database backup, let's say, if you want to automate a database backup, you don't know, let's say you don't know shell scripting or Python scripting, you don't know how to get started. Just write a good prompt. You get a proper script, right? And then you can just add on top of it and you can just do this, right? Similarly for other things, right? Or other automation ideas.
Yeah.
You want to search, let's say you don't know uh, how do we
Even
search a text. Yes, yes, go ahead, Nasima.
right, Roshan. Yeah, I do agree on your point. Like at least like we need to have a good understanding like how we can provide the prompt to get the even automation or like a,
Yeah.
performance
Prompt engineering.
script, right? So before going with that, you need to have the detailed understanding of like how the architecture has designed and how the layers has been deployed and how the integration has been moved into the uh, different applications. Maybe they may be deployed in the Kubernetes cluster or a cloud infra. These items like you may not have end-to-end detailed understanding or end-to-end development experience, but you should have to have the understanding at least like you should have to have the understanding of the process.
Exactly. So what you're talking about, Nasima, is the fundamentals. See,
Right.
even to use Gen AI tools, if our fundamentals are not strong, we cannot make use of it, right? It's
Right.
like somebody wants to write one essay in English, right? But let's say the person is not, he doesn't like, the person is not comfortable with English, then it's very difficult, right? To even use Gen AI tools to do copy paste, do some tweaking. So we should be at least be comfortable. It's, for example, the cloud part. Just now, Nasima talked about cloud, infra, containers, Kubernetes, right? If we do not understand the basics, what is cloud, what it offers, different services that we have, how do we use it, then if somebody wants to get in details, we would not be able to ask the right prompt, right? So at least the fundamentals even to use Gen AI tools to take us to the next level of our better version of ourselves, we should have the basic understanding on cloud containers. Containers leads to Kubernetes, right? If the application is deployed in Kubernetes, and let's say we do not understand what is containers, we should have the basic understanding that what is a container, where does it create, where we create in the VM, what it is, right? How it gets created, how it is different from the VM installation. If we do not have that basic understanding, we would not be able to even put the right prompt and get use of Gen AI tools. So yes, I totally agree with all of you, and I think everybody has mentioned yes. I see Anthony Das, uh, Srinivas, Henry, right? Everybody is agreeing that we all need to know this. For example, microservices. If you do not understand the importance of microservices over monolithic, what it brings to the table on the application availability, again, we would not be able to ask more questions. We should understand how asynchronous communication works. What is synchronous, asynchronous communication? What is the use of Kafka? Let's say somebody doesn't know what is Kafka. or how to do asynchronous communication, what prompt will you give? Right? For example, let's say RDS, a relational database, MySQL. So you should have that understanding that we have various kinds of databases. We have relational databases, NoSQL databases, and at least the basics. Even if we want to write the query, select query, we can write the good prompt for the select query, but we should have that. If we should be able to understand when we get to see the query, select what is the format of a query being written. So fundamentals is absolutely required to even Gen AI tools, and these four things are very much relevant in today's market. I'll tell you the why. Okay, I'm going to show you the next slide, then you will understand why these things are important. Look at this. When you look at this slide, you will understand that we are transitioning. When the software development deployment started around 1970s, 1980s, right? We are just 50 to 60 years software industry has started. So if you look at the transition, we are currently in this phase where we are talking about DevOps. We have transitioned from waterfall to agile to DevOps on the development process. Earlier, uh, if you go back in time, we didn't have DevOps, right? That time we had a waterfall model. It has some demerits. We learned from our mistakes. We moved to agile. Again, it had some demerits. It took a lot of time when the code was ready because all the steps were manual. Now we are talking about how can we automate most of the steps, CI/CD pipeline, right? Same one thing on a monolithic. If you look at back then, we were deploying all the code base together like a single packed unit. Mono means single, lithic means big. Now we understand the importance of splitting the code base. It gives us reliability, availability for the application architecture, right? On the infrastructure, we were deploying everything on the physical server back then. We were wasting a lot of resources. A lot of resources were getting underutilization. Then virtualization came into picture and it revolutionized the way we are deploying things. That earlier we were directly deploying on the physical servers. If some tiny little application that we used to develop, few KBs, MBs software, we used to deploy in a physical server. When the virtualization came, at least we could leverage most of the infrastructure and we could install many softwares in each of the VMs, virtual machines. Uh, and then we are in the containers world nowadays. I would like to just ask a question before I go to the next part on the cloud. I would like to ask a question on this. Friends, do we know the application that you work on currently? Your application, whatever application that you are working in a company, right? Your application, whether you are a support engineer or a performance engineer or an automation engineer or a developer, anybody across. Do you know your infrastructure, your application is running in the VM or is it running in a container? Do we know this simple answer? Say yes or no. Let's be open about it. I would like to just see a poll here of yes and no. Do you know where it is running? Is it running in the VM or is it running in the container? Do you know or not? That's all simple.
Yes, we know. Yeah, I know.
Perfect. That's good. Uh, Feel free to, if you do not know, no, friends, absolutely fine. I understand. Sometimes we do not have that insights. We don't get the access. I have been talking to many people and I am able to understand this pain point. So I am raising this question. Right? I see a couple of no also, but most of the people know about it. That's good. I tell you, I I interact more like from many people right across. They ping me. I go to attend workshops. One of the major problem at the I'm talking about performance engineers. Now you all understand. As a performance engineer, friends, if we do not know the underlying infra, can we do capacity planning? Is it possible for us to do capacity planning? Without knowing the infrastructure,
No.
can we do capacity planning?
No, it's not
Right.
possible.
Not possible.
Yeah.
That is
Even
the
if you know
problem.
the,
Go ahead. Yes.
sorry. So even if you know the production volume and the production capacity, so yeah, you need to have the understanding of the infra.
Infra, right? Absolutely not. We cannot do capacity planning. And as a performance engineer, when I interact, I get to see people who don't understand. As a performance engineer, our one of the core responsibility is to size the application in prod, right? Because we performance engineers are the ones who run the load test, who try to simulate prod scenario. And performance engineers are the best people in a company, not the architect, not the developer. I have been getting different answers. Performance engineers are the best people in the company to talk about what would be the infra required in production. Do we all agree on this?
Yes.
Who runs the load test? Who runs the prod load test? Who try to mimic the prod scenario? Performance engineers, right?
Performance engineers. Yeah.
If performance engineer will not tell you the infra required in prod, then who will tell you? Who will suggest that? Well, we know the load and the infra ratio. We understand core, we understand memory, we understand if I run 10% of the prod load, this much infra is required. To run 100% of the prod load, how much infra would be required? Right? So that's very important. Earlier, because why I asked this question, because there's very much people get confused here, right? First of all, they do not understand is it running in the VM or is it running in the container. Okay, it's running in the container. Then if it's is it Kubernetes or it is Docker, is it just a container or it's a Kubernetes, right? Or any other orchestration engine? That's very important, right? The understanding of the infrastructure is very important. Okay, and we have been transition, right? Virtualization around 2000 was a great revolution. We were able to optimize the resources when we moved from physical server to virtualization. Nowadays, in 2015, containers came and it has revolutionized again the way we deploy our application. How many of us here use containers? Just I would like to say yes in the chat. Uh, how many of you use containers in the production for deploying your application? Friends, yes or no? Just quick answer. I am seeing yes from Nashimha. Okay, perfect. Good. Gokul, Amit, Srinivas. Okay, so Srinivas using no. Okay. Okay, Henry. Okay, yes, but I'm removed from it. Okay. Okay, right. So nowadays, if you look at the trend, right, people are using containers. Friend, do we know why people are using containers nowadays? One simple question to understand what is the main benefit here of what has been the objective from physical server to virtual server to the VMs to the container. What has been the objective here? What is the main objective? Let's see if somebody can answer that. What is the main objective of this transition? We have been transitioning from physical server to VMs to container. What is the main objective?
Maintenance, easy maintenance.
Okay. Any other inputs?
I think it basically overcomes the
Cost.
Absolutely. Absolutely. Cost. Cost, friends. We will not compromise on the performance, right? If cost has been the main factor. We were wasting resources here. We had more core, more RAM, but we were using deploying some tiny little application here. We were wasting resources. Then we on this same physical server, we installed software like virtualization software, virtualization, and we could create VMs, VM1, VM2, VM3. We deployed our web server, app server, database server in each of the VMs. One VM. Think your laptop is a one VM. Your laptop has core, your RAM, same. VM has the same configuration. They have the RAM, they have the OS, they have the cores. Your laptop is also a VM. Now, In one VM, it was observed that the utilization was not 100% or 80%. Most of the VMs utilization was around 20 to 30%. Now tell me one thing, is it a good practice? If you have asked me 8 cores, you're using only 2 cores. Are we wasting resources or not?
Yes.
Yes, Roshan. Yes.
That is where
Yes,
containers
you are.
came, right? That is where the containers came. So containers ensured that in one VM, I can deploy as many applications till its capacity. Okay, now if you need additional, let's say you can say, Roshan, what about if the load increases? Yeah, we have auto scaling. If the load increases, let's create one more VM, but use only get the new VM when you require, right? So just to keep things simple, let's say you have a 3-tier application: web server, app server, database server. Let's say you, I'll 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 make this simple. I don't want to confuse, so let me just draw a picture so that everybody is on the same page. That's very important understanding. So let's say you have 3-tier application: web server, app server, okay, database server. Let's say I'm using 8 cores, 16 GB in each. Okay, 8 core, 16 GB in each. 8 cores. I hope everybody understands, right? The core and the RAM. 8 core, 16 GB is the configuration of the VM. Like our laptop has also a configuration, right? Depending on how many cores and the RAM we have, our laptop has also the configuration. Let's say we have the web server, app server, database server. I am using 2 cores in each. When I am doing when I'm running in production, it was observed that we are hardly using 2 to 2.5 cores. Usage, effective usage I'm talking about. Cores, okay, let's focus on only the cores, 2 to 2.5 cores across, let's say. That has been the normal setup, right? And if you look at this is the usage. If you look at this, we are not utilizing the VM to full capacity. And we are thinking like, okay, there could be a case where more load would come in. That's why you have given additional bandwidth, additional headroom, just to accommodate more traffic in the worst scenario. That's why you are not decreasing making it to 4 core, right? You're not doing that because you may anticipate some load and you want some headroom to accommodate the traffic. But if effectively over the months, you have been using this much cores. Now, what the container did? Now, what containers solve the problem and how cost optimization works in containers? That now you get only one VM. And now, what did you do in this VM? Same 8 cores VM. There is no change here. 8 cores VM only. 8 cores and 16 GB VM. You got it. You containerize it. You install some software. You containerize it. And then in the same VM, we create 3 containers. Container 1, container 2, container 3. What is this container for? This is for the web container, this is for the app container, this is for the database container. Now, earlier we had 3 VMs. Web server is installed in one VM, app in another, database in the third VM. Now, in this containerization, you created in the same VM, you created 3 containers, and you're in one container you're running web, other you're running app, and you in the third container you have the database. And you have also configured auto scaling for the worst scenario that if the load increases, you will get another VM. Now think about it, friends. I would like you to think. Do you think that I will be over let's talk about 1 year. Do you think I'll be able to save a lot of cost for 1 year if I go with containers, this approach? And I can handle the same load. How many of you agree with that? That yes, with the containers, yes, definitely we can optimize the cost. That's how we optimize the cost. Friends, is everybody on the same page? You can ask question, Roshan, what about if the load increases? Here you have the headroom, here you don't have the headroom. You can ask this question. I would answer you that I have auto scaling configured. If there is a requirement, more load has come in, okay, but that's not triggering often, right? So I would get additional VM for that brief amount of time. I would get additional VM for that duration when the auto scaling is required. But eventually, I would be able to save a lot of cores over the years. Yes, Henry has a question. Henry, go ahead.
So why couldn't we have the VMs smaller? Is it because the VMs then have OS and a whole bunch of things, and the container then is more lightweight?
Absolutely.
Okay.
Absolutely. Absolutely. See, you can auto scale here also. In the VM also you can auto scale. Containers auto scale also is there. We have both kinds of things. VM auto scaling you can also do. But again, here you have OS requirement, you have heavy. So you have OS here also, but you have only one VM where you have the OS. Here you have three VMs, right? So if effectively, eventually, over the years, you will be able to optimize the cost in the containers without compromising on the performance, security, or any of the aspect. Right? That's why people go towards containers. And same thing will happen for the applications, right? On the monolithic world. I'll tell you this example. What is monolithic? When you put all the code together, right? As a single tight unit, dependency, the function, you have lot of modules and you packaging every code base together. When I say packaging, let's say you are writing the code in Java, you have multiple modules, multiple functionality, right? I'll give you one example, okay, better to understand. I will, let me make it simple. Let's say you have this application called Make My Trip. Okay. You have got various modules here. You can take similar example of Amazon.com or Flipkart.com. Same thing. Let's say you have various modules, flights, hotels, villas, holidays, trains, booking train tickets. You have so many modules. So it has got three components. Web server, where you're seeing the UI. I'm not focusing on the web server, focus on the app server, the logic, where you have the logic. So when I click on, let's say, one destination to another destination to a date, when I click on search, a lot of things calculation happens, right? It will make API call to all the flight carriers. They'll get a response in some JSON or XML format. They will parse it and they will display in the user-friendly UI where I could understand things, right? So a lot of things happening in the backend. A lot of calculations is happening. A lot of code is being written at the backend for the application server I'm talking about. So focus is on the application server. Same thing, calculation happen. I will have a different processing for the hotels, for the villas, for holidays. Focus on the app server, not the web server, right? So I'll take another one simple example. So let's say you have the three-tier application. Okay. Focus again. Let's say this is the web component, web server, and let's say this is the application server where the code is being written, the logic, and let's say this is the database server where you are taking the data. So focus it on the app server. You have a lot of code being written, right? So and because you have got modules, various modules. You have the flights module, trains module, villas module. You have buses module. Like a lot of modules. You have various functionality. And in what you're doing in each of the modules, you're writing the code. You're writing the functions. And when I say monolithic, you are packaging it together. You are basically, the functions are being called anywhere and everywhere. There's a huge dependency of the code. Let's say this module. Okay, I have a better example. Already have a diagram. Let me just, we can save some time. Quickly give you a diagram. Okay, focus it on this. Okay, So I have the web server. Look at this. So I have got various modules. M1, M2, M3, M4. And what are we doing in this module? We are writing functions. And in the monolithic world, the functions are being called anywhere and everywhere. There is a huge dependency. If I'm writing F21, I'm calling function from M1, M2, M3, huge dependency. And I'm packaging it together. Let's say if I'm writing the code in Java, I'm getting one jar file or a one war file. And everything is packaged together. That's called monolithic. Mono means single, lithic means big. All the code packaged together. Huge dependency. What is the problem? I would like to understand from you. Do you see any problem with monolithic? Why we had to go to microservices? What do you think, friends? What could be the problem here? Let's hear it from you. Anybody?
Hi, Roshan. Yeah, so
Yes.
because this is a dependency related.
Yeah.
So if monolithic, then each module is dependent to another one. So that's why we are using a microservices.
Okay, what is the problem, Amit? That's what I'm telling. Why you had to go to microservices? What is the problem?
Problem is this because if any module or any function is not working, then another module or a whole functionality will be you can say it's a crash or something. So
Right.
we are moving to a microservices.
Right. So as Amit mentioned that if F1 has an issue, one of the functions in M1 has one issue. And since M1 is being called, this function is being called anywhere and everywhere across other modules. If F1 has an issue, it can potentially bring down the application. It will have a cascading effect because of dependency. That's what Amit mentioned. So will you like that statement? Will you like any application? If I say, if my flight module is not working, you're not able to book hotels. Will you like such application?
No.
You will simply think, why flight module has to do with the hotels? I'm just giving you one example, right? Within one application, you want segregation, right? Even if one functionality is not working, you don't want other functionality to break. And that's exactly the problem happens with the monolithic applications because of the dependency. Now, how to solve this problem? Split it, make it independent. That's it, simple. Make it microservices. Earlier, you get only one jar file because the code were dependent. Make it independent. M1 dependent, M2 independent, M3 independent, M4 independent. Let's have a different independent deployments being done for M1, M2, M3, M4. Let's not all the functions. If you want to install information from M2, okay, have the APIs have exposed the APIs, get call, post call, put call, patch call, delete call, expose the API, get things done. But don't call the functions directly. Remove the dependency, right? Similarly, like how if I make my trip, the moment I clicked on search, right? The moment I clicked on search, the call went to various flight carriers, right? API call was made to various flight carriers. Indigo, Akash Air, Air India, SpiceJet. A lot of APIs call were made. Is Make My Trip dependent on SpiceJet? If SpiceJet is down, will my Make My Trip will be down? Will be impacted? No. I'm calling the API. They know, but I'm able to use the information, right? This flight carrier, they have exposed their APIs, and all Make My Trip is doing making the call. Make My Trip has purchased, must be paying for the API that's being called. So that's what Make My Trip is, must be paying monthly basis, right, or yearly as per their agreement. And through APIs, we're able to get the SpiceJet details, flight details, their booking, their timings, right? So that's what two microservices communicate with each other through API. So the idea here is to make the modules independent of each other so that they can be deployed separately, independently of each other. Here, even if I'm making a small change in F1, I have to deploy the entire code base. Yes or no? In monolithic, because everything is dependent. But here, if I'm making a code change in F1 or F2, I will have to only deploy M1, the code in M1. So I hope we are on the same page. We're able to understand the importance of monolithic to microservices, friends. And all the development is happening, most of the development is happening in the microservices world, right? Same on the development process. Okay, friends, are we on the same page? Can I get a quick thumbs up? Are we good with the containers and the microservices? These two parts? Quick thumbs up. You have a reaction in the teams. You can give a thumbs up. Any questions? Feel free to ask any question. Okay, perfect. Now, if we look at the development process, what is this? Earlier, friends, we had waterfall approach. What is the waterfall approach? Developed, let's say I'm developing one application. We have now in the waterfall, the approach, it's all about the approach of development. SDLC, software development lifecycle models, we call it. SDLC models. Waterfall, in waterfall, the approach was, I'll draw a simple diagram. It's the approach was whatever the software that I had, various modules, application that I had, we will first do the development, complete the development part. Every module, it could have 100 features. We will first develop all the 100 features. And then once it is developed and all the 100 features are developed, then only we will test. What could be the problem? What has been the problem? What could be the problem here, friends? This is the waterfall. What could be the problem here, friends?
If there is a issue or something is going wrong, then the process of identifying or fixing it is very costly.
Absolutely, right? You developed everything. And at the end, after 6 to 8 months, you're realizing when you started to test, it's not scaling. What will you do now? The architecture has a flaw. What will you do now? You are in a very pathetic situation, right? Now, other problem, we are not taking the feedback from the client. Okay, we have discussed with the client once. That's it. Okay, I will freeze the features. Let's get started with the development. We'll get back to you when the development is ready. We are not showing some prototype. We are not giving some demo. We are not taking continuous feedback from the client. When you look at something prototype, you may get some ideas. When you discuss, brainstorm, you get some ideas. You are not having that opportunity, right, of taking a continuous feedback from the customer. So major problem, right? So that's why we learned from that's the first thing that we do, right? So that's good. We are learned from our mistakes, and then we improved. What did we do? We split that development into phases, sprints. We call that's agile process, right? That's what we did next. The same development we split into phases. Phase one we did, right? We split into phases. Phase 1, phase 2, phase 3, we call them as sprints. Okay, let's target few features only, right? That is what is the agile process. Let's target few features. Let's do proper testing for that feature. Let's take feedback. That's the agile process. So we did, right? So we split the development into phases, right? Various phases, we split our development. We did all the SDLC steps. We did testing, performance testing, security testing, QA testing. We did all sorts of testing in each of the sprints. We took feedback also from the customer, and then we passed the feedback to the next sprint. Again, we did SDLC. So here the end result is going to be much better than this. Yes or no? In the agile. Friends, able to understand?
Yes.
Right. Now, the agile had a problem because the things were done manually. When the code is ready, I would like to ask this question from all of you. I want you to think. When the code is ready, what is the eventual goal? Eventual goal. When the code is ready, friends.
You have to integrate with other models.
Repeat that.
You have to integrate with the other models.
No, that's fine. When the code you have integrated, code is ready. What do you want to do with that code?
We need to deploy and start the testing.
Testing is a intermediate phase. We want to eventual goal is to deploy that code to production. That's the eventual goal, right?
Right.
Simple, simple. Testing comes in transition. As a part of is part of the process. But when the code is ready, we want to deploy the code to production. But we cannot do that. We should not do that. We should check quality of the code. We should check functionality, performance, security. We should do that, right? But the eventual goal is to deploy the code to production. So when the code was ready, so there are two major steps, right? Two major things, right? So I'm talking about the problem with the agile. What is the problem with the agile? That we took longer time. When the code is ready, whether it's agile process, whatever, when the code is ready, our eventual goal is to deploy that code to production. That's our eventual goal. And we have steps in between, right? We want to deploy that code to production. But we have so many steps like the functional testing, performance testing, security testing, UAT testing. We need to do that to check the quality of the code before we deploy. But if things are done manually, let's just think about it. Functional testing is done manually. Okay, performance team is waiting. Okay, let the functional complete, then we'll start. Functional testing has created bugs. They're working with the developer. Then only performance team can take the fixes, then take the code. They did the load testing, they do capacity planning, security testing can do in parallel. So when the things are done manually, it takes a lot of time. Think about from the owner of the company. Will you like if the code was ready a month back and you are deploying the code now after a month? Will you like such a process? Don't you think we should try to expedite this process? You will get this natural idea of, right, when the code is ready, why can't we automate all the quality validation steps, QA steps? Because only thing that was remaining was quality validations. Can we do these steps in an automated fashion? Can we have the scripts ready? Can we do the manual steps in an automated manner? Why can't shift left can be done? Why can't functional team, performance team, security team can work with the developer when things are working? They can take the requirement, they can start building the script, and when the code is ready, they can quickly run their scripts and get code to prod. That's a generic, just organic idea, right? Yes or no?
Yeah,
That should
but
be the way it should be.
I have a question. So
Right.
here, the quality and the validation is important, right? Like here, the code is ready, and you deploy like with
No,
automation process.
we are not skipping. We are not trying to skip anything here. We are trying to expedite the process. That is the main objective here.
Okay.
Objective is not to skip the quality validation. Objective is to how to minimize the time. It took a month. It took 2 months because things were done manually. It took 2 months. Will you like such an application or such a process? That's the question we're talking about. It took 2 months. The code was ready and it took 2 months to deploy the code to prod. That's the problem we are dealing here. And that is the problem with the agile. Because things were done manually. What would you do in such case? Everybody. Will you try to minimize this time or yes or no?
Yes. We see some
How?
alternative options with some automate process.
We are not talking about skipping any steps, Siba. We are not talking about don't do functional testing, don't do perform. We are not talking about that. We're talking about can all the teams do the shift left approach, can work with the developer when things are in the development phase. Can they understand the requirement? Functional team can understand the requirement. They can start writing the test cases. As soon as the API is ready, when the development is done, they work with the developer, they start writing the test cases. Performance team starts getting the non-functional requirements. Security team can be ready with the scans. Can that be done shift left approach with automation? This will reduce the time, yes or no? 2 months to 15 days. That is what we call it CI/CD pipeline. That is the process we are doing. And that is what DevOps is all about. DevOps is all about how do the operations and developer collaborate with each other to minimize this delay through automation. So DevOps is all about SDLC, process automation. How can we do a continuous development, testing, deployment, how it is possible to do everything in a continuous fashion, in an automated fashion. And that is what we're talking about here. So, right? Okay, I hope we got this. Friends, are you on the same page? What we are talking about in DevOps, what DevOps focuses on?
Can you please explain the DevOps? If you click.
Same thing, right? Automation. Automate this, all these steps to automate. What is the process? When the code is ready, what do we do?
So from what step it goes? Like, if you
I'm asking you, Siva, let's keep it simple. When the code is ready, what is the next step?
uh, when the code is ready, we test. If it quality is good, then we deploy.
Correct? So in the test, what are different phases are there? What type of testing we do?
We do first they do unit testing, then we do functional testing, then integration testing, then performance testing.
Security testing. If things are done manually, it will take 2 months. So to
Yes.
automate the process, CI/CD pipeline using tools like Jenkins, things can be automated one after the another, right? That is what DevOps focuses on. We will have an elaborate discussion in the course, right? That's what we'll talk about it. Let's not go in deep right now. We are trying to discuss the course syllabus. We'll come to that. Just try to understand the high level. You understood the high level, right? We are talking about automation here. How do we automate? We will discuss that in the course, Siba.
Okay.
Right? Okay, friends, everybody on the same page that we need to automate these steps here so that we can reduce the time to deploy the code when the code is ready, right? Friends, everybody on the same page? Quick thumbs up. Okay. Now, the last thing, friends. Now, where do we deploy? Where do we deploy the code? Where is the infra? Earlier, if you had a business idea, we had to set up a data center. Not everybody can afford to set up a data center. Not everybody. It's a very costly affair. Setting up a data center, you understand the problems, friends? Set up what is a data center looks like. This is what a data center looks like. I'm going to show you a data center photo. Image. Okay. This is a data center looks like. Okay, I'll just show you. Okay. This is a data center facility looks like. Multi-story building in the outskirts of a city, multiple acres of land, all the big rooms full of hardware like this. These servers will generate enormous heat. Think about our laptop generates heat. Think about billions of such laptops, what they will do. So this server generate enormous heat. You have to maintain the cooling. The data centers will have to secure. So you'll have a security personnel. The data center will have hardware engineers to check the hardware health of all the infrastructure. These data centers cannot run out of electricity. They will have multiple redundant power sources. So very costly affair. Billions of dollars goes into. If you have a business idea, earlier there was no option. Oracle, IBM, big players can only afford, Amazon.com, they can only afford to set up a data center. Microsoft, Google. Today, why we see so many business, Swiggy, Zomato, Ola, Uber, where are they getting infrastructure from? Friends, where are they getting infrastructure? Do you think they have their own data center?
No.
No.
No. Not everybody can afford to have such an initial overhead, right? Capex. So friends, there are providers in the market, AWS, Azure, GCP, they provide infrastructure like a rent basis. What is a cloud? When you own the data center, we call it on-prem. But when you leverage somebody else hardware, let's say Amazon.com, AWS, they have set up data centers across the globe. But I need the servers to deploy my application. So I need servers, right? I need servers, I need storage. Netflix is hosted in AWS. They have a lot of storage, they have a lot of people, the load is there, Hotstar, everything is in the cloud. Streaming platform, they need infrastructure, they need storage. If they go ahead and set up their own data center, their business would not flourish. They cannot, not everybody can afford to have such initial overhead capex requirement. So they go use the cloud provider, they pay monthly bill. Like how we stay in a rented apartment. As long as we pay the rent, we can enjoy the services. Right? Same thing. So when Netflix use AWS, they don't own the hardware, they just pay the rent for the servers, for the storage they use monthly basis, right? So we have providers. So all the infrastructure that we are talking about, deployment, VMs, right? Code deployment, the infrastructure is from the cloud. So we need to understand, right? So we need to have a thorough understanding of how applications are being deployed, where is the storage comes into picture. Then only we can do capacity planning, we can do improve the performance. We need to understand the IOPS requirement. So we should have a thorough understanding of the cloud, right? So that is where, friends, these four things are so relevant because this is the current trend. This is where we are living in this phase, right? And that's why these four things are so relevant, so important. And that's why everybody needs to, all the software engineers need to know all of these things, right? Now, when I asked this question in the beginning, few of you may have doubt why Roshan is asking this, how these things are related. Now, do we all understand? Do we have the context better now? Why these things are so important nowadays? Friends, do we all agree on this?
Yes.
Where it fits into the bigger picture, right? So that is where these things are so important. Now, this course that we are talking about, SRE course, Cloud Performance Engine in a DevOps course, this course is based on these four things. We are talking about fundamentals in this course. We are taking up AWS from scratch. I don't need any prerequisite knowledge. You don't need to have a prerequisite knowledge to attend this course. I can teach a 12 standard, 10 standard also if they're interested, right? This course is designed in that manner. Yeah, Raji, I'll let me complete, Raji. Yes, go ahead. Let's see your question. Go ahead, Raj. What's your question?
Uh, Roshan, like if we are deploying our code or are hosting our data on a third-party systems, right? So are
Hmm.
we not compromising on that data security and privacy and that kind of?
Yeah, that's a very valid question, but cloud has security. Think about, right? Bigger players like Netflix, they are deploying in AWS. They must have validated that it's secure, right? And they're running from so long. NASA uses AWS. So they must have checked all these things because they have security services also. They have why cloud business is flourishing so much because they have got that trust that their data is secure. They have security services because of the security services they offer. We'll talk about security services also in the cloud. We have in the course how it is secure, how why it is why it's not easy uh, to hack of the application in the cloud. We'll discuss that. So we have a security services in detail. We'll cover that in the course. Raj.
Okay, thank you, Roshan.
Sure. Okay, so let me just get to the context, friends, of the course. So this course is designed on these four. Okay, Raj, you can lower your hand, Raj, please. Thank you. Okay, see, this course is designed on these four aspects. On the cloud part, we are talking about AWS from scratch. Okay, you don't need to have a prerequisite knowledge to learn to attend this course, right? To do well in this course. Raj, you still have a question? You have raised your hand still.
I'm joining from my mobile. I'm not able to lower my hand.
Okay. No problem. I thought I'm gonna help you here. Okay, I have done that. Thank you. Now, on the containers, friends, we are talking about Docker, Kubernetes, and in detail. Okay, detail to a level. Even if you are 10 year, 12 years experience from scratch, for you to get till you can justify your 10 to 12 experience also to that level in the cloud to the containers. When we talk about containers, we're talking about Docker, Kubernetes. Okay, Anthony has a question on the cloud. What is the level of certification we're talking about? Anthony, we are targeting here Solution Architect Associate, SAC03, but with some guidance because this course is not okay. So we covering the basics up to 60% of the course of SAC03, Solution Architect Associate. We will be covering. After that, you just need to understand few more services to attempt the certification. I'll guide you also on that. What needs to be done after the course to get certified. Sounds good, Anthony? Perfect. Now, on the microservices, friends, we are talking about monolithic microservice architecture. We're talking about how asynchronous communication works on the architecture also, right? What synchronous, asynchronous communication, what is event-driven application architecture works, synchronous. So we give examples, we'll understand this on the architecture perspective. On the DevOps part, we're talking about CI/CD pipeline, and everything is hands-on, okay? No theory. Everything is hands-on. When I'm talking about cloud, we all will be having the cloud account. We will be doing hands-on. So I'll be basically doing hands-on. You can do in parallel with me if you can manage the time, right? We cannot spend a lot of time, we cannot give you a lot of time in the session during the session, but while we'll be doing the hands-on, you'll have the recorded session. You can go later also, you can practice. But if you can manage the time along with me, we go slow, steady and slow we go. So you can also do hands-on along with me, right? Uh, we talk about CI/CD pipeline, Jenkins. So when I say we're going to install Jenkins, we're going to have a server, we will install Java, Jenkins dependency. Jenkins is Java based tool. So we'll install Java, we'll install Jenkins. I'm going to create a pipeline, creating jobs. I will show you how do we create a job, how performance testing works. How do you create a Jmeter job? How it's exactly pipeline. We'll discuss that, right? CI/CD pipeline. So that is what we deal here in this course, right? And we have much more things, right, in this course. I'm going to show you, friends, what all we cover in this course. Let me just explain more in detail. I'll go to the course syllabus now. Okay. This is the website where you have the details. Let me share the uh, link first of all. Please keep this handy for link. I've just shared the link in the chat. Friends, if you see this, we are talking about from the cloud perspective, AWS. What all we covering in AWS, you have the details. I'll not go over it. Everybody would not be able to understand, but we are covering enough for you to justify 10, 12 experience, right? Enough. And see, you can say how different it is from other cloud courses. See, we are covering from four perspectives. See, we focus on four aspects. We focus on cost optimization. How do you optimize the cost? When I talk about cloud, our focus is on the cost optimization. How do we optimize the cost in the cloud? My focus is on the high availability. How do you make sure your application is highly available? My focus is on the reliability. How do you make sure, see, failures will happen. Failures will happen, but how do you make sure that the failures does not long, like it should not be for longer time. It should be, we should be able to remediate the impact. How do you make sure the application is reliable? Reliability, right? We're talking about performance. So we cover all the topics, cloud topics from these 4 points, very much specific. If I talk about EC2, we're going to talk about not just the EC2, not just about the performance, not just about the instance type, but how do you optimize the cost also in EC2. Storage, how Netflix is able to manage the cost. They have so much of storage content, but how they are optimizing the cost without losing the content, without losing the data, how they're optimizing the cost, how they are making sure that the application is reliable. How do you take care of, how do they take care of disaster recovery? How do you take care of high availability from the architecture perspective? So we cover all the topics from these 4 domains, right? That's what we focus on here. So every topic here in the cloud, we focus on these 4, right? And that is how we take up every topic. What now? I'm going to ask a question, friends, to you. Do you know why I have this Linux module? You'll understand that. Do you know 95% to 99% of the deployment happens in which OS? Anybody?
Linux.
Linux.
Do we all agree? Right. Now, is it important for us to be comfortable with Linux? If I want to troubleshoot an application, don't you think we need to be comfortable logging to the Linux machine, issuing some commands, getting comfortable because our application is running there? We should be able to understand the health of the Linux systems. Is it important or not?
Yes.
Yes.
Yes. What has been the case, friend, that we are comfortable more with Windows. We know how to check Windows CPU. I know how much core this Chrome is taking, this Teams application is taking. We have task. Maybe we are very much comfortable with Windows. But same thing applies for Linux also. Why are we not comfortable with Linux? That is the point. I can see all the processes running. Why can't we check all the processes like this in Windows, in Linux? Why can't I check what is the problem? If why my application is slow, why can't we check this? Like this kind of details, right? So it's all about getting comfortable. How do we check the logs in Linux? Do we know how to navigate through a file in Linux? If I ask you, if I ask you in Windows, okay, you have a file, replace a word in a text file in Windows. Everybody can do that. Control F, Control G. We all know that. But can you do the same steps in Linux? Can you check the logs? Can you check the errors? Can you find for the specific word in a file in Linux? You have a file, I'll give you a file, Linux machine. Can you search for a text, all the errors word? How many errors are there?
No.
Right? That is the we are talking about, because I understand the pain point. That's why we have added the Linux module. Right? So we are talking about Linux again from scratch. You don't need to have prerequisite of Linux knowledge. My tagline is simple: get as comfortable with Linux as you're with Windows. We're talking about Linux here. Again, I'll not go in detail. You can go over that in detail in the link. I have shared the link. We talk about SRE. There are some terminologies we should be get comfortable with. What is disaster recovery? How do we achieve disaster recovery? Companies like Amazon.com, NASDAQ, NSC, Flipkart, they cannot afford to have downtime. If they had a downtime, they will lose business revenue. How do they ensure they're highly available? How do they ensure even if the data center is down, fails, that they're still available? We'll talk about those things because what matters the most. Let's think about you are Flipkart owner or Make My Trip owner. What matters the most? User experience matters the most, right? For me, if I'm the owner of a website like Amazon.com or any retail e-commerce, application user experience matters the most. When I say user experience, the availability of the application, the performance of the application, that matters the most. So how do we achieve that? We'll discuss about those things, terminologies. Say lows, measure the uh, errors. We'll discuss that, right? On the architecture, monolithic microservices, event-driven architecture, asynchronous, synchronous, asynchronous. We'll discuss that. Now on the containers, we discuss how do we create containers, how do we deploy applications in the containers. So we'll talk about Docker, Kubernetes. We talk about auto scaling. How do you auto scale in containers? We also talked about auto scaling of in VMs. How do we auto scale in VMs? How do we auto scaling in containers? We discuss about both. That's very important for the production systems because load may increase or decrease. We want automated setup of the auto scaling. That's one of the very important criteria. Right? That even if the more load is comes, our application should be capable enough to handle. We talk about security services. We should also know when to block. We should be also understand how do we block a traffic. How do we know that somebody is trying to do malicious behavior? Somebody is trying to bring my application down, DDoS attack. We all know load testing tool, right? If I ask you send 1,000 requests per second to Amazon.com, can everybody do that? Yes or no? Yes, friends. We know load Jmeter, LoadRunner. If I ask you, you have a website, Amazon.com, hit this website with 1,000 requests per second. Can everybody do that?
Yes.
No,
Everybody
manually
can.
we can't do, but we
Yeah.
can do
I'm not
some
asking
other.
manually. Nobody can do manually, right? I'm talking about the tools.
Yeah.
But don't you think Amazon.com should be capable enough to understand that it's a attack and they should be able to block the IP? Somebody
Yes.
can try to. That's what DDoS attack is all about. So how do you secure application, right? So we discussed about those things in this course. Security services. We have various security services in the cloud. DDoS. How do you protect DDoS attack? So any application has to be ready to understand this to make the application secure. This kind of attacks does happen, right? Uh, so container Kubernetes. We talk about DevOps. We talk about Jenkins, CI/CD pipeline, shift left approach. Can we do? Can you do production testing in production? We talked about shift left approach, which will expedite the process of code deployment to the production. We do the hands-on, everything is hands-on, CI/CD pipeline, Jenkins, right? We talk about how do we gain resiliency and reliability in AWS. We have a lot of services in AWS which we can use because the eventual goal is to make my application highly available, secure, reliable.
Oh, for performance, right? Here
Mhm.
we are testing the. Are we using some tool from AWS or we are
No,
doing?
we are not talking about performance testing tool here.
Okay, then
Our agenda is not to learn a JMeter tool here, right?
okay.
Our agenda is on these four aspects: cloud, containers, microservices, DevOps. That has been the SRE. That is what we're talking about. I have nowhere mentioned that we are going to learn JMeter here. This is not a performance testing.
No, they
Yeah.
in the four aspect, right? In the first we saw, the last one was the performance, right?
Where it is,
Uh,
I'm not
when
able to understand.
you shared in the
No,
first
you
one.
mentioned the 4 points, right?
Yeah,
Uh-huh.
the four
In
points
that, the
one.
last
Okay,
one, it
see
is.
performance. When I say, okay, I get it. When I say performance, I'm talking about infrastructure. How do you take care from the infrastructure perspective? From the Kubernetes, we'll talk about auto scaling. We talk about right sizing the pod, right sizing the VM. We will talk about from the if I talk about EC2, how can you achieve good performance from the EC2 sizing? We have the core and the RAM. We have various specifications on the storage. We have IOPS. So performance is a very vast domain. We are not talking about tool. We're talking about engineering here.
Okay.
Yeah. So
Yeah,
Roshan, like in engineering, do we cover any monitoring aspect?
Correct, correct. I'm coming there. I'm coming there. I'm not done with my thing. So, right. So
Uh,
we'll talk. Okay. So we talk
Roshan,
about.
just a quick question.
Go ahead.
I mean, performance is so one is the application performance, infrastructure performance, network performance. Performance is multi-phase. It has multi-phases, right? So, are we gonna, as part of this course, are we going to
Yeah,
cover
I got your
application
question.
performance
Yeah.
engineering,
Yes, yes,
network
yes.
performance
I'm
engineering?
coming. Can if everybody can give me some 5 minutes, I will be able to understand more about the course. Just give me 5 minutes. Okay, more. I just need. So yes, to answer your question, yes, we are talking about here application performance engineering and infrastructure performance engineering. These two aspects. So on the performance, application performance engineering, we are talking about Java performance engineering, mostly the Java applications, because still Java is the most popular programming language. Spring Boot. So we talk about Java performance engineering here, and through AWS we talk about infrastructure performance engineering. So these two aspects we are covering. Sounds good. I hope we understood the
Yes.
scope,
Yeah.
right?
A cloud watch. What is a cloud
Yeah,
watch?
I'm coming there. Coming there.
Okay.
It's okay. Just please. I request everybody to give me 5 minutes. Let
Okay.
me
Okay. Sure.
Okay, you will be able to, your most of the question will be cleared. Okay, so coming to how do we achieve resilience and reliability in AWS, we talk about this. We have observability, right? How do we monitor things, right? We use Linux monitoring using like commands like top, mpstat, sar commands. We have free df. We talk about those things. We have CloudWatch. AWS out of the box service, CloudWatch is the monitoring tool of AWS. So since we're using AWS services, it integrates with all the AWS services for the monitoring, right? On the open source, we talk about Prometheus and Grafana and Elastic Stack. So you can say, Dawson, why are we not taking commercial tools? Commercial tools, we already get a lot of support when you buy a commercial tool. So we talk about open source here, open source products. We take up these two open source products. CloudWatch is the AWS specifics and Linux. If you do not have any tool, how can you monitor things? So we cover about these things on the observability monitoring part. We talk about Java performance engineering, as I told you here in this course. We talk about automation. How do you achieve, how can you automate mundane steps? So we talk about Terraform, infrastructure provisioning. See, in production, we have thousands of servers. Do you think people are creating those 1,000 servers, deploying application manually? Is it possible in production? No, it's just not possible. So we use tools like Terraform, Ansible, right? So we discuss about these things, right, in this. So we talk about shell scripting and Python scripting in this course. How do we do that? Using GenAI tools, having basic understanding of shell scripting, Python scripting, using GenAI tools. How can we leverage? How can we go to the next level of our automation? Right? So we explore on the GenAI tools. We understand the basics and we use GenAI tools to get to that level of automation. That is what we cover in this course, the scope. As part of we are providing you the Java core. This is not my session. They are somebody very good at Isha, self-paced core Java and Python programming. So it will be also additionally provided as part of the course, right? So if you look at the sum it up, friends, we talk about these four aspects: the cloud, containers, we talk about Docker, Kubernetes, microservices, monolithic architecture perspective, we talk about DevOps, we talk about monitoring tools, we talk about application performance engineering, platform performance engineering is anyway we're talking about through the AWS, we talk about automation, we talk about monitoring. So that is what the scope of the course, right? Uh, yeah. Any questions I can take it up now, friends. Go ahead.
Uh, Roshan, I have never did cloud. I was not into cloud performance engineering. Most of my performance testing and performance engineering activity was on on-premise environments. I'm just wondering how different is performance engineering in cloud to compared to on-premise.
Huge difference, right? All the AWS services you will not have in on-premise. All the AWS services that we have in cloud, you do not have in on-premise. If I talk about EBS, if I talk about security, your on-premise, you need to develop. In AWS, you get ready-made. But when you join a company, you people are using AWS more than the on-premise. So people will expect you to learn cloud, to know cloud, to
Um,
use AWS services, to understand infrastructure, performance engineering. How do we do that? For example, if I ask you a question, if you're having an IOPS problem, what would you do? Input output per second. If you are experiencing an application having high IO, what would you do? So when I talk about cloud, I will talk about storage options that you have. I'm going to talk about the EBS services that you have and the IOPS options that we have in AWS. How do you achieve IOPS from the infrastructure perspective? We have options GP2, GP3, IO1, IO2. We'll discuss on that lines. So when I talk about databases, relational databases, right? How do you achieve high availability in the on-premise? In the cloud, you have RDS, which is managed database. But how do you achieve high availability in on-premise? How do you make sure read replicas are being created in on-premise? So it's a totally different world in on-premise as compared to cloud.
I understand from the infrastructure point of view, there's significant difference, but from application point of view, application performance engineering point of view, is there
No,
any
there's no difference.
not
Once
much
the
difference?
infrastructure is there, application is application, right? It's irrespective of the cloud infra. Application is
Mhm.
the code, right? Code is common in both.
Yeah.
If the code has issue, you have to optimize the code in both.
So if I optimize the code in an on-premise environment and then deploy it on a cloud, that would do, right? I don't have.
Absolutely, you're fixing the performance issue of the code. That is one of the roles, right? As a performance engineer, what do? We optimize the code. Why do we take heap dump, thread dump? Why do we get to that method level? Why we talk to the developers to find the root cause of memory, which code is taking more memory, where my threads are getting hung? Why we discuss all those things? Because we try to optimize the code. That is the same common process. Either you're in cloud or you're on-prem, it doesn't matter. You are writing the code. We're trying to optimize the code. You are writing better data structure algorithm. If you see one processing taking a lot of time, let's say developer has put a lot of for loops. You saw the unnecessary for loop is being added, and they are taking a lot of cores because of that, lot of memory because of that. You would suggest the developer why you are using so many for loops. You can simply do with this data structure, right? So that's a code optimization. That's irrespective of the cloud.
Okay. So my understanding from what you shared is, so if we have an on-premise environment, do all the application performance engineering related activity there and just deploy it in the cloud. Or
Yeah,
if you do directly on the cloud also, it doesn't, there's
doesn't
not a
matter.
lot of,
How would you expect
okay,
the code to get fixed when you deploy in the cloud? Cloud is just giving you infra.
correct. Yeah, that's what I was thinking. But even in this approach, right, the cloud part, it comes with a additional overhead of maintenance and monitoring the infrastructure structure. Uh,
When I say
uh,
overhead is in the on-prem or the cloud.
in the cloud, so we have a
How
multiple. So
come? So you don't think we have overhead? Why people are using cloud more than the on-premise? Don't you think in on-premise we have more overhead of buying the hardware, maintaining the hardware, having the security personnel to secure the premises? Don't you think we have so many other things we have to do you have to do the virtualization, you have to install. In the cloud, you get everything ready-made. Everything is
Mhm.
ready, right? When you it's like a service apartment, full-fledged service apartment. You just come here and stay. But if you try to build your own home, you have to purchase the land, to construct the building, buy everything, maintain everything. So that's a difference, right?
Okay.
I think you got a basic understanding, right? How do you?
Yes. Yeah.
I go to a place living in a service apartment, full fledged service, fully furnished service apartment. I can just simply go with my luggage. I can enjoy there. But think about you now. You need to in that place. You need to buy your own land, purchase the home, construct the building, buy all the things. That is what the on-premise and cloud is all about.
Okay. Got it.
Overhead is there in on, and you need more cost, right? You need more capex in the on-premise. Not everybody can afford to have on-premise. You cannot leave the home now alone. You have to have the security personnel. Somebody will do theft, will damage. You have to do a lot of things. More overhead is in on-premise. In the cloud tomorrow, I don't want to use the server. Today I decide I need 10 more servers. Today I decide. Tomorrow I don't need. Fine. But in on-premise, once you decide 10 servers, you have to purchase the hardware. Now, whether you use it or not, you have to pay for it because you have already purchased.
Oh,
There is more overhead.
just curious, Roshan, what are the disadvantages? Like there are advantages and disadvantages to every solution, right? So what are the disadvantages of going for the cloud approach over on-premise?
See,
I don't know if I'm
it's not about the advantage. It's all about can you afford?
Okay.
Can you afford to have your on-premise? Can everybody afford?
Mhm.
If you ask Swiggy, Zomato, Ola, Uber, get your own on-premise, they will say, sorry, I cannot open my business only.
Mhm.
Initial overhead, that's the major problem, right? And yes, if you have on-premise, you have your security, you have to develop everything, right? And then you own it. You know what you're doing. You have more security, you can say that, but cloud offers security. Your data will be not, you can encrypt your data. We have a lot of security services in cloud. That's why people use cloud, right? They trust. Why NASA, company like NASA, they use cloud? Why don't they have their own on-premise? Yes, Divya.
So actually, like in this session, we are going to cover only what are the topics that is there, or like, is there anything like CICD you mentioned, right? So
Correct.
actually, I'm mainly looking for the course because of these things, right? Container, these things I already using. My main intention is like using the CI/CD pipeline and how to like integrate end-to-end performance testing. Say, for example, if you already have your scripts and everything in Git, just take that one and run the pipeline and all these
We
things. Is
exactly
that
do that.
also
We
covered?
exactly we exactly do that. If you read this, Jenkins integrates with JMeter, we do that.
Okay,
We integrate Jenkins with Jmeter. We will have a Jmeter job. We will see how do we
mhm,
trigger Jmeter from Jenkins job or in an automated manner. We will learn that. So we have a complete demonstration of CI/CD pipeline. We talk about Git, Docker Hub. We talk about these things.
okay, okay, fine. Actually, like we are using the Neoload tool. So is it specifically only for
No, you can
JMeter
use
or else like,
anything. You can use any tool. Jmeter, Jenkins can integrate with any tool. Jenkins have a
okay,
plugin for Neoload also. I believe
okay,
Jenkins Neoload plugin. Let me check it. Must be Jenkins is very popular because of look at this. We have the plugin already. So use this plugin
got
and
it.
plug it with Jenkins. Similar plugin we have for the JMeter. Use this plugin to connect to Neoload. You
Okay,
have this
got it.
plugin.
Because yeah, mainly like I'm looking for that end-to-end performance testing where we can able to like get the things and
Right. Look at
automatically
this.
run
You have
it.
this plugin. You have the plugin.
Okay,
Yes.
okay,
Neoload
yeah, fine.
plugin is there. That's why we're talking about Jenkins. Jenkins is the why Jenkins is popular because you can integrate Docker, you can integrate Kubernetes, you can integrate Jmeter, LoadRunner, Dynatrace, AppDynamics, uh, Grafana, anything you can integrate with Jenkins. That's why Jenkins is so popular. CI/CD
Got
tool.
it. Okay. Yeah,
Yes,
mainly
Gokul.
my
Go ahead.
intention is that. Yeah.
Yes, Gokul.
Yeah, Roshan. My question is that, like, just looking at the overview of this course, will the at the end of the course, will we be enough to take on cloud performance engineering roles as well as some roles in cloud domain specifically, like cloud engineers? Is this enough? Good
Absolutely.
enough?
Absolutely, Gokul. If you I need your 3 months of time. Okay. I need your 3 months. I need your dedicated. After the session, I need your dedication for 1 hour to 2 hours daily basis. If you do
Mm-hmm.
that, I can
Mm-hmm.
promise you that in 3 months you will have a huge difference, provided you put your efforts. Just by attending the course, you need to do hands-on practice with me, right? If
Right.
you commit 1 hour to 2 hours on daily basis, I can promise you that. But if you do not
Okay.
commit, I would not be able to promise because I am going to deliver. But can you take it up? Because you need this commitment.
Yes.
It needs this
So
commitment. Yeah.
yeah, my that is what I was asking because it's like is it just restricted to performance part or we can just go on about taking the cloud roles as well?
Cloud
That
roles.
was yeah.
Cloud we are covering so extensively, Gokul.
Mm-hmm. Mm-hmm.
Cloud role, SRE, DevOps, cloud engineer, production support. You can take any role after this course.
Oh, is it okay? And
Yeah, Roshan, I have
are
one
we be
question.
going to sorry, Thiru,
Yeah,
just
tell
one
me.
last question. Uh,
Yeah.
just one last question,
Go ahead,
Roshan.
go ahead.
Like,
Go
will
ahead.
we be implementing some sort of a project as well, which we can just put on our portfolio or something like that?
See, once you have the understanding of each and everything, right?
Mm-hmm.
I'm going to demonstrate you an application which you can talk about.
Mm-hmm.
Application architecture, I will demonstrate you a Kubernetes architecture, an application or a 3-tier web application. I'm going to demonstrate you, and you can put that in your resume. You can explain that, work that through, and you'd be able to through that. Yes, we do
Okay,
demonstrate those architecture. Yes.
understood. Yeah, that's all. Thank you.
Yeah, Roshan, I have one question.
Yeah.
So
Yeah.
if I enroll for this course, is this course is related to cloud performance testing or completely related to SRE, or
See,
SRE or cloud
hmm.
performance testing are both are same?
See, that's a very good question. There are a lot of overlap. See, that's what you need to understand. What is your aspiration is. See, as an SRE, what is our main goal? Our main goal is in production. We want production to be highly available, reliable, secure, performing. When I say performance engineering, so there is a lot of overlap here. 70% of the role is overlapped. That is why that's why we have clubbed this course and put this together. Cloud performance engineering and DevOps, there are 70% of the overlap is there in the expectations because they are also dealing with the cloud. You're also dealing with the performance engineering. Basically, you are doing the troubleshooting. Here you have some additional stuff like alerting, monitoring, setting up monitoring, and that is what we are automation, and that's why this course is relevant to both as well as the
Like
DevOps.
auto scale up and scale down are coming under cloud performance testing, right? Not comes under SRE, right?
See, again, you are not clear on what SRE does. That is the question you are raising. If you, as a SRE, you are responsible for the user experience. Now, when I come user experience, everything comes into picture. You don't need to set it up, but if you do not have the understanding whether the problem is because of auto scaling or not, how will you discuss with the performance engineer to work on that issue? So as an SRE, one of the important things is that you should be able to drill down where is the problem happening. So you need to have multi-skill to be a good SRE engineer. You should understand you should be able to troubleshoot the problem. Let's say problem will come in production. Response time is 1 second. It was used to be 200 millisecond. Now it's 1 second. What will you do as an SRE engineer? Tell me.
Sorry, I didn't get you. Can you please come again?
You are responsible for production, correct? As an
Okay.
SRE engineer. Now in the
Okay.
production you're observing response time has increased to 1 second. It used to be
Okay. Okay.
200 millisecond, now it has increased 1 second. What will you do
Mm.
as an SRE engineer?
We have to check whether the response time is from the application side, database side, or front end level. We have to check, right?
Correct? You
Yeah.
answered your own question. You have to check whether auto scaling worked or not. You have to check whether the problem with the infra or not. You have to check whether uh, problem with the database or not. You have to check, you have to drill down the issue, right?
Yes.
You
Yes.
answered your own question, Thiru.
Yes.
You got my point, which I'm trying to tell you.
Yeah. Can you please explain in detail so that I can come to know?
Just now you mentioned, Thiru, that to find the root cause of this, you will have to check a lot of things, correct?
Yes.
Auto scale working or not, whether the problem with the infra or not, whether the
Okay.
problem with the web server, app server, database server or not.
Okay.
So don't you think these things are overlapping? Whatever the performance engineer does in lower environment, you are doing the same thing in prod.
Okay. Got it.
That's
Okay.
why I
What?
say then, go ahead.
Okay, one more question I have. As part of cloud performance engineering, we are going to use like AWS, Microsoft App Insight, and GCP, Google Cloud platforms. Coming to SRE, what tools we will use as part of SRE roles and responsibilities?
See again, okay, I think you need to understand the roles and responsibility. That is where the lack is. We are talking about fundamentals here. Okay,
Okay.
fundamental is common in both. Either you see, as a performance tester, you know Jmeter. That is the scope we are talking about. But when you go to
Okay.
cloud, your entire domain expands. You need to know
Okay.
Kubernetes. You should know cloud. You should know automation, CI/CD pipeline, and that is the exact scope of SRE. So there is no
Okay.
tool specific. You can use for monitoring tool, alerting tool. You can use these kind of tools, but there is no
Okay.
such tool like JMeter which will help you do SRE job, right? It's the one of the
Okay.
same thing. It's incident management tool like PagerDuty where you get alerts. Those kind of tools, simple tools. There is no such specific tools for SRE as such.
Okay.
It is same monitoring tools, observability tools, PagerDuty alerts you can get where you get alerts because that is where you know the problem, right? So you need some
Mhm.
integration. You get some SMS, PagerDuty alerts. So it's like a alerting mechanism. So there is no
Okay.
specific tool as SRE as such.
Okay. Like I had somewhere Gremlin is a SRE
Yeah,
related
yeah,
tool.
that is chaos engineering again. So again, only for the chaos part.
Okay.
Only for the chaos engineering, we have Gremlin to do chaos
Okay.
testing. Again, you can do
Okay.
manually also. You can use some tools like Gremlin, take help of Gremlin. That's only for
Okay.
one scope of SRE. Gremlin is
Okay.
not the entire tool of SRE. See, you
Okay.
need to do what is chaos?
Mm.
We are trying to simulate the prod issue, prod behavior. So what do?
Okay.
We on purpose we bring applications down. We bring the load balancer down. We bring the web server down. We bring the application server down, and we try to understand the impact in production. That is what Gremlin tool would do, right?
Okay.
They try to make failures, purposeful
Okay.
failures in the system to understand the impact, because as an SRE engineer our role is to make sure production is highly available, reliable, performing, right? So
Okay.
but if the failures happen, what will happen? They try to mimic that. That is what the Gremlin tools is all about. It's not
Okay.
the complete, there is same skill set is there. You
Okay.
are trying to understand what I'm trying to say.
Yes.
You
Yes.
right? So you can bring the application down yourself, bring the load balancer down, bring the server down and check the impact. Are you getting status code, different status code? Are you getting 400, 500 or still getting 200? How long it takes for the server to auto scale? These things only you need to check eventually.
Okay. Got it.
Okay, so we'll continue. Okay, I understand you have a lot of questions. Friends, we'll continue tomorrow. Okay, please join
Tomorrow at
tomorrow,
the same time, right?
same time, 8 a.m. Try
Okay.
to
8
join
a.m. to
tomorrow.
9:30.
Yeah, 8 to 9. Yes. 9,
Okay.
9:30
Fine.
will not be there. 8 to 9, I plan to 8 to 9, but because of the questions we had expanded that today.
Yeah.
Tomorrow,
Obviously, we will ask.
yeah, that's no, that's fine. So tomorrow we'll continue. Okay, whatever the pending questions are there, we'll continue tomorrow 8 a.m. Let's understand more about the course. Tomorrow we'll ask questions. You will have definitely good insights. I hope your this 1 hour is worth, friends, spending with me. I made your time worth. Can I get a thumbs up from all of you if you all agree? Got insights? Good, right? That is the main objective. You should have your time worth spent. Okay, perfect. We'll meet tomorrow and discuss further. Thank you so much, everybody.
Can I get this recording, right?
Thank you.
Yes,
Thank
we
you.
will. Everybody would get. Thank you so much.
Thank you.